Students, here's a fun little lab. It's called Everyday Acids and Bases. And the point is, acids and bases are all around us at all times, even in the foods that we eat. One of those foods, cabbage, has some pigments in it. And pigments, the pigments that are in red cabbage, happen to be natural indicators. So what I'm going to do is put a few pieces of cabbage into a blender. I'm going to add some tap water to the blender. We're going to turn this on. Pardon the noise. Nice and well mixed. Now what we're going to do is take this cabbage juice and add it to several different household substances. But before we do that, we're going to add it to some known bases and acids. So I have a solution of sodium hydroxide, and I have a solution that's a known acid, acetic acid. We're going to see what color the cabbage juice turns when it comes into contact with these known acids and bases, and then compare it to what the cabbage juice color becomes when it's in contact with numerous other things that you might find around your house. So we do need to take this cabbage juice and heat it up. So in just a moment, in fact, what I'll do is I'll pause the video until we've had a chance to boil the cabbage juice for about 2 or 3 minutes. And then when we come back, we'll start our testing. Okay, students, so the cabbage juice has had a chance to heat up and boil for a few minutes. I've poured it into this beaker. Notice it's purplish on its own. What we're going to do is mix it with a known base, a known acid, and water, and see what color it turns. Those are going to be our standard solutions. Then we're going to mix cabbage juice with each of several different household substances like dishwashing soap, apple juice, ammonia cleaner, vegetable oil, Mountain Dew, lemonade, 7-Up, laundry detergent, hand soap, cleaning solvent, and even a Pedialyte beverage. So let's see what happens first when we add some cabbage juice to each of our mixing plates. So here I'm going to add just a couple of drops of cabbage juice to each of these mixing plates. You may notice that we've got a purplish color. I have to angle this a little better here. Okay, so cabbage juice across all three. Now what I'm going to do is add to this well, I'm going to add some base. This is sodium hydroxide. Notice the color change. It's like a bluish greenish color. To the middle well, I'm going to add a known acid. Notice the color change. It's reddish in color now. And to the well on the right, I'm going to add a little bit of water. No noticeable color change, but it may have gotten a little bit lighter, become a slightly lighter purple color. Okay, so these are our standards. The base became bluish greenish. The acid became reddish. The water stayed purple, although it may have been slightly less intense coloring. Those are our standards. Now, let's play around with some household substances. I'm going to add cabbage juice to all of the wells. Put about 4 or 5 drops in each of the wells, and then we're just going to test some things. In the data table, I'd like you to record what you see in the standards. And then what we're going to do in just a moment, one by one, we'll test some household substances. Okay, so we've got the cabbage juice added to all 12 wells. Now, one at a time, we're going to test these substances. Let's start with vegetable oil. This is the stuff that you would get in the grocery store. Maybe it's in your kitchen somewhere. I'm just going to take a few squirts of vegetable oil, and I'll put it in the well located in this corner. I don't know if you can see that too well. There's no color change except the oil did not mix well with the cabbage juice. It's no particular color change noticeable with vegetable oil. Let's try ammonia cleaner. I'm going to put that in this well directly next to the vegetable oil. Here, aha. Do you notice the greenish bluish color? So this color matches what we saw with sodium hydroxide, a known base. That would lead us to believe that perhaps ammonia cleaner is basic. Lemonade. I'll add the lemonade to the well next to the ammonia cleaner. Aha. Do you see the color? It's reddish, which matches what we see when we added acetic acid to cabbage juice. So that would lead us to believe that lemonade is perhaps acidic. Mountain Dew. I'll add the Mountain Dew to the well on the right. We also see a reddish color when Mountain Dew is added, which would lead us to believe Mountain Dew is an acid. Cleaning solvent. This is like 409, stuff that you would put on your kitchen surfaces to make them clean. I'm going to add the 409 to this well, so middle row. It's very bubbly. We see the same color change as we saw with the ammonia cleaner. So both the cleaning solvent like 409 and ammonia have a similar reaction, which might lead us to conclude that this is a base. Seven Up. I'll add the 7-Up to this well. Similar to the other drinks we've seen, the lemonade and the Mountain Dew so far, we see a reddish color with 7-Up, which again would lead us to believe that 7-Up is probably acidic. Apple juice. I'll add the apple juice next to where the lemonade was added. And here, not quite red, but it is yellowish. So not red, but yellowish, maybe slightly less acidic than the other drinks, but still not the same color as what we found with the household solvents. Laundry detergent. I'll add this one to the right side here. Very bubbly. No noticeable color change. Laundry detergent did not change any color, or did not cause the cabbage juice to change color. Dishwashing soap. I'll add this to the front row here. We mix it a little bit. The dishwashing soap is naturally blue, so I wouldn't say that that blue color is necessarily indicative of a base. In fact, I'm not seeing any noticeable color change here. Hand soap. Having a hard time getting this out here. I'll pour. Maybe I'll use a squirter. We add the hand soap to this well. Again, one thing that's a little hard is the hand soap has a natural orange color, but I'm seeing reddish color here. So hand soap, at least this particular kind, soft soap brand, seems to be acidic. It's changing the same color as what we saw with the standard when we had a known acid added to the cabbage juice. All right, one last substance, Pedialyte. Pedialyte is a beverage like Gatorade. And kind of like the other drinks, we see a reddish color indicating an acid. If you take a look at the data table, students, it asks you to tell us, is it an acid or base? Describe the cabbage juice color, and then give an approximate pH. Now, when you give an approximate pH, students, I am A-okay if you simply say acidic, or below 7 for acidic, above 7 for basic, or equal to 7 if you indicate neutral. The other questions kind of ask you to generalize. So are cleaning products generally acidic, basic, or neutral? Based on your results, what would you say? Are foods and beverages generally acidic, basic, or neutral? And then question 4 is an interesting one. Remember, we used cabbage leaves and we blended them up in a blender. So there are several pigments. The same pigments that you see in cabbage leaves are also seen in autumn leaves. So it asks you to think about, okay, trees and leaves, and what kinds of, how can we use the substances around us to learn about acids and bases? Thanks for your good work. Good luck on the lab.